1A homework. Let's take a look at the first one together. Let's just go over some things real quickly. Okay, so that's the general form that you see there. In that general form, the absolute value of A is your amplitude. If that happens to be negative, it's going to flip it upside down. If you set Bx equal to 2 pi, you're just going to solve that for x, and that is going to be the length of one period of your graph. So that's the period. If you want to find the starting place of your graph, or if you want to find how it moves left and right, so the start of your graph or the phase shift, you're going to set the parentheses bx minus c equal to 0. The end of your graph, you're going to set bx minus c equal to 2 pi. And then we're going to break those x's down from there. And then finally, the vertical shift is just d. The midline is just y equals d. So those are the main things that you want to know. So if you know the facts that you see there, those same exact facts are going to work when we get to do a cosine. So there you go. Okay, so over here to the side of our first problem, we want to do the chart for the original sine function. Okay, we're going to do a chart for the original sine function. So if we think about as the sine goes around the unit circle, doing every pi over 2. So we're talking about 0, pi over 2, pi, 3 pi over 2, and 2 pi. What happens to the sine values? What happens to the y's as we go around the unit circle? Well, it starts at 0, goes up to 1, back to 0, down to -1, and back to 0 again. On the sine function, these three values are always on that midline. So it's always going to be touching the middle 3 times on a sine function. Okay? So keep that in mind as we go through this process. So let's find everything that we have seen for problem number 1. So this value right here is going to tell us our amplitude. So it is just the absolute value of 2 or 2. Now, if that number was negative, instead of our sine function make it a bump up, then a bump down, it would flip over and do a bump down, then up. Okay, but this one goes up, then down. Let's talk about the period. The period, we're going to use this term right there. We just set that equal to 2 pi and solve for x. Well, has anything changed? No, because the x is just an x. When that happens, our length from start to end of one wave is 2 pi. The phase shift, remember, we are going to set the bx minus c equal to 0. So I'm talking about that parenthesis, whatever that parenthesis is. That's going to be our starting place on our graph. We're going to set that equal to 0. We're going to solve that for x. So our starting place is pi over 2. So put that on your chart. So our phase shift is pi over 2. We've technically picked up the graph. We have shifted it to the right, a pi over 2. Now, before we move on to midline and vertical shift, that is the starting place of our graph. Let's find the ending place of our graph. We set that same parenthesis now equal to the end spot, which normally is 2 pi, but now we have shifted it or changed it a little bit. How do we do that? Well, we're going to add a half of a pi to both sides to solve for x. Well, think about fractions. I know you guys don't like fractions, but if I said to add 2 1/2, you'd get 2 1/2, or 5 halves, right? If you broke it down into halves. So this is 5 pi over 2. Now let's think about what's exactly between 1 and 5. Tell me, what's exactly between the numbers 1 and 5? 3. So what's exactly between 1/2 and 5 halves is 3/2. So just use logic to find this exact middle. Exactly between 1/2 and 3/2 is 5/2. Now, let's go in between that. What is between 1 and 3? What's between 1 and 3? 2, right? So that would be 2/2, or exactly 1 whole. What's between 3 and 5? 4/2. So 4/2 is 2 pi. So now we've found the x's that we're going to be using throughout the process. So now we are ready to talk about the vertical shift or the midline. The vertical shift or midline is determined by anything that you have added or subtracted. If there was no number here, it would be 0. The middle would be at 0. But our midline is y equals 1. That tells me that I've gone up 1. That is the only difference between midline and vertical shift. Vertical shift, you can actually say, like even phase shift, I could say to the right. Vertical shift, you could say up or down. If it's positive, we went up. If it's negative, we went down. The first thing we're going to put on our graph paper are the x values and that fit. So let's put on pi over 2's. I got to get to 5 of them. So if I go 1, 3, or 1, 2, 1, 2, 3, 4, not enough. Okay, so let's just make this pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, and you get the drift. Okay, so that's how we're going to count our x's. Now you decide how you count them. If you mark it a little different along your graph paper, I'm okay with that, but you have to always mark it to tell me how you were counting. Now, the last thing we got to find before we graph are our y values. So how do we do the y's? Well, this is going to be 2 times the old y plus 1. We have forced the old y's to be used. So you're just going to do 2 times the old y plus 1. So we have the old y's listed here. That's why we list them. Okay. So our first one's going to be 2 times 0 plus 1, which is 1. Our next one's going to be 2 times 1 plus 1, which is 3. The next one's going to be 2 times 0 plus 1, which is 1. The next one's going to be 2 times negative 1, which is negative 2, plus 1 is negative 1. And then our last one is going to be 2 times 0, or 0 plus 1. Now, again, I've mentioned on a sine function, these 3 should always be on your midline. So you'll notice that all of those ended up being at a height of 1. So our highest value is 3. Our lowest value is negative 1. So we're just going to count by, normal ones. Okay. So the first thing you put on your graph paper, please, is your middle line, that midline at 1. So do that. Now that's going to be where we're going to go up 2, because our amplitude is 2. We're going to go up 2, down 2, up 2, down 2. Okay, so let's put on our points. Okay, so our first point at pi over 2, we're at a height of 1. At pi, we're at a height of 3. At 3 pi over 2, we are at a height of 1. Remember, the first 3 points of a sine function give you its first bump, whether it's going up or going down. So what do we notice? Well, we notice it's shifted to the right, and it's stretched up 2 up. So the next one's going to be, it should be 2 down, but let's just check for that. At 2 pi, we're down at negative 1. At 5 pi over 2, we are back on the middle line, so we have a bump. Now, that graph is just not right there. That graph stretches across the graph paper. So follow equal spacing. It is always equally spaced, and it always is going up then down, up then down. So equally spaced, make another bump up. equally spaced, make another bump down. Go the opposite way. We were up, so now we got to go down. We were down, so now we got to go up. Now we got to go down. They are equally spaced. They were equally height throughout your entire graph paper. So that is how you graph a sine function. Hopefully that has kind of helped you with that process. You have 3 more to go. Keep going. There you go.